Okay, so here is the second lesson for section 5.3, which is all about the slope of line segments. So 5.3, slope day 2. Let's start off by just quickly reviewing how to find the slope of a line segment using our formula, slope equals rise divided by run. And remember, rise is your change in the y-coordinates, or another way to think of it is your vertical distance between 2 points, and your run is your change in the x-coordinates, or your horizontal distance between 2 points. And you also have to remember that the vertical axis is the y-axis, the horizontal axis is your x-axis. So if I want to find the slope for number 1 right here, if I want to find the slope of this line, you need 2 points on the line, so it gives you 2 points. Any 2 points on the line will work, okay? So you don't have to use these two. You could use, this point here and this point here. It's up to you, but it gives us 2 points, so we'll use the 2 that it gives us. And I want to find the steepness of the line using these 2 points. So to get from one point to the other, I need to figure out what the rise and the run is. So what's my rise? What's the vertical distance between these 2 points? Well, I have to go up. I have to rise. Oh, I don't want to be clicking on that. I want to rise 1, 2, 3, 4 units to get from point A, I'll call this point A, to point B. It has a vertical distance between these 2 points of 4 units. And I'm going from A to B, I have to go up 4 units. Okay, so that means my rise is 4. Now the horizontal distance between the 2 points will give me my run. So I have to go right 1, 2, 3, 4, 5, 6 units. So my rise was 4. My run is 6 because the horizontal distance between the 2 points is 6 units. Going to the right gives me a positive value. So my run is 6, so my slope is 4 over 6. I'll put that into lowest terms. 2 goes into both 4 and 6. It goes into 4 twice. It goes into 6 3 times. So my slope is 2/3. And it's a positive slope because the line goes up to the right. For this line here, for number 2, this line's going down to the right, so I know my slope is going to be negative. Okay, let's figure out what the slope actually is. So to go from point A to point B, I need to figure out what's my rise. So rise is vertical distance between the 2 points. To get from point A to point B, I have to go down 1, 2, 3, 4, 5, 6. I have to go down 6 units. Okay, I know when I'm going down, that gives me a negative rise. So my rise is negative 6. And then the horizontal distance between the 2 points will give me my run. I'm going to the right 1, 2, 3, 4 units. Going to the right gives me a positive value, so positive 4. Okay, so negative 6 over 4, put that into lowest terms. 2 goes into 6 and 4. It goes into negative 6, negative 3 times. It goes into 4 twice. So negative 3 over 2 is the slope for the line in question number 2. Question number 3, let's figure out the slope for line A, B. Whoops, I wrote A for both of them. Line A, B. So I need to figure out what's the rise and the run. Remember, rise is the vertical distance between the 2 points. So to get from A to B, I have to go up 1, 2. Going in the upwards direction gives me a positive rise. So my rise is 2 divided by my run. The run is the horizontal distance between 2 points. 1, 2, 3, 4, 5, 6, 7, 8. So I have to go 8 units to the right to get from A to B. So that means my run is 8 because going to the right is a positive value. 2/8 put into lowest terms is 1/4 because 2 goes into 2 once, goes into 8 4 times. So my slope is 1 over 4. And good, it's a positive slope. I knew it would be positive because my line goes up to the right. For number 4, the line goes down to the right, so I know it's going to have a negative slope. So to calculate the slope, I need 2 points on the line. Any 2 points will work, but it gives me 2 points, so I'll use the 2 points it gives me. The rise is the vertical distance between 2 points, so it goes down 1, 2. Okay, I know going in the downward direction gives me a negative rise, so my rise is negative 2. And my run, to get from the first point to the second point, I have to go to the right 1 unit. I know going to the right gives me a positive run value, so it gives me a run of 1, negative 2 over 1. I can just write that as negative 2, because negative 2 divided by 1 is negative 2. Okay, so my slope is negative 2. I knew it would be negative because it goes down to the right. Okay, and I think I'll just show you that it just proved to you that it doesn't matter which 2 points you choose. Okay, so I got negative 2 when I used the 2 points it gave me. What if I decided to use this point, and let's say I used this point way down here. Let's say I calculated the slope between those 2 points. Well, to get from the first point to the second point, I would have to go down 1, 2, 3, 4, 5, 6 units. Going down, I know gives me a negative rise, so -6. And my run, I'm going right 1, 2, 3 units. I know going to the right gives me a positive run, so +3. -6 divided by 3, once again, is -2. So I got the same slope. So no matter what 2 points you use on the line, you'll get the same slope, as long as it's a straight line, of course. Okay. What we're going to do now that's a little bit different than before, we're going to draw a graph. So if I give you a point, I give you a slope, I want you to use that point and the slope to actually graph the line and tell me other coordinates that are on that line. Okay. So a line segment has one endpoint at A, 4, 7. So I know a coordinate is an x, y coordinate. So that tells me that when x is 4, 1, 2, 3, 4, y is 7. 1, 2, 3, 4, 5, 6, 7. Okay, so this is point A right here. So a line segment has that endpoint, and it has a slope of -3/2. I want to find the coordinates of another possible endpoint B. So step number 1 was to plot that point A at 4, 7. I did that. Step 2 is to use my slope of -3/2 to find another endpoint. Okay, what I want you to note here is that, so look at this right here, -3/2 is equal to -3/2. You can move this negative sign to the numerator or to the denominator. It really doesn't matter. It'll just that'll just determine whether you're finding a point to the right of A or to the left of A. Okay, but if you put the negative in the numerator or the denominator, it'll both give you points on the line. Okay, so let's put it into the numerator. That means that our rise is -3 and our run is 2. So to plot another point, so reading this section here, to plot another point, start at point A and use the slope of the line to plot another point. So starting at A, I know this line has a rise of -3, so that means go down 3. So go down 3, 1, whoops, so I'm going to go down 3, down 1, 2, 3, and then it has a run of 2. I know that means go to the right 2, so 1, 2, and I'm going to plot a point right there, and that's my new point. I'll call that point B. Okay, I'm just going to erase these arrows. Okay, so I've found a new point B by starting at A and going down 3 and right 2. So that's my rise, my run have told me to do. Okay, so the rise of 3 told me that we had to go down 3 units, because I know a negative rise tells me to go down. And the run of 2 told me I should go right 2 units, because I know the run is the horizontal distance, and I know if it's positive, that means we go to the right. So another possible endpoint, so I found point B. What are the coordinates of point B? Well, on the x-axis it's at 1, 2, 3, 4, 5, 6. On the y-axis it's at 1, 2, 3, 4. So it's at point 6, 4. That's another possible point. Okay. Note there's an infinite number of points on the line that goes through A, B. Okay. So the line that goes through that will look something like, it'll look something like this. And there's an infinite number of points on this line. So if I had have used, remember it told us that it had a slope of -3/2, and we decided to move that negative sign to the numerator. That's perfectly fine, okay? But -3/2, it has the exact same value as 3 over -2. Exact same value, okay? If you type that in your calculator, you'll get the exact same value of -1.5. Type both of those in on your calculator, you get the same value. These are identical slopes. Okay? Depending on which one you use, that will depend on whether you find a point to the left or to the right of your starting point. Okay? So, for example, we used the slope of -3/2. So that told us it had a rise of -3, so go down 3, a run of 2, go right 2. It gave us point B. If we had have used the other slope, 3 over -2, if we had to move the negative to the denominator, that would have told us to have a rise of 3, so it would have told us to go up 3, 1, 2, 3, and then a run of 2. So we're told us to go left 2. So 1, 2. And it would have given us this point right here, which is also on the line. Okay? So depending on which slope you use, it'll give you a different point on the line in a different direction from your starting point. But it will give you a point on the line as well, no matter which of those two slopes you use. Okay? So hopefully you see that. Okay? So I've just explained to you why there's an infinite number of solutions, what would happen if we use a slope of 3 over negative 2. So I just showed you that. Okay? Example 2. If a line has a slope of negative 1 over 2 and the line passes through the point 4, 5, determine the coordinates of 2 points to the left, 2 points to the right on the same line. So I want you to notice again, negative 1 over 2 equals negative 1 over 2 or 1 over negative 2. Exact same thing. All three things have the same value of negative 0.5. This negative sign can roam anywhere it wants. It can be in front of the fraction in the numerator or the denominator. But in order to actually state what a rise and our run are, we have to decide whether we want it to be in the numerator or the denominator. Okay? If we put it in the numerator, okay, that'll give us points to the right of our starting point. If we put it in the denominator, that'll give us points to the left of our starting point. Okay? So in this case, we want 2 points to the left and to the right. Okay, so we're going to have to use this slope and this slope. So let's do that. So our starting point is at 4, 5. And remember, a coordinate is an x, y coordinate. So let's plot this point at 4, 5. 1, 2, 3, 4. 2, 3, 1, 2, 3, 4, 5. Okay, there's my starting point. So I'll start by using the slope of negative 1 over 2. So that means that it has a rise of negative 1, so go down 1, and then a run of positive 2, so go right 2. So there's my next point. The coordinates of that point are 1, 2, 3, 4, 5, 6. X coordinate is 6, y coordinate is 1, 2, 3, 4, 4. So when x is 6, so it's a point to the right. When x is 6, y was 4. And then let's keep going to the right, so I'll use the same slope, so go down 1 again, and then right 2. The coordinates of this point are 8, 3. So I'll put those in my table of values. Now it also says I want points to the left. So to find points to the left, all I have to do is do the exact opposite slope of what I just did. So I just went down 1, right 2, so I just have to go up 1 and left 2 to find points to the other side. Okay? And I can do that using the slope, moving the negative sign to the denominator instead of the numerator. So I'm using the slope of 1 over negative 2. So that means a rise of 1, a run of negative 2. So up 1, left 2. That gives me another point on this line. And the coordinates of this point are 2, 6. And then use that same slope one more time. So up 1, left 2 again. It gives me the new point. Oops, sorry. Up 1. Yep, so it gives me a new point at, I don't know what happened here. Try and delete that. Okay, gives me the new point at 0, 7. Okay, so I've found 2 points to the left, 2 points to the right. And if I connect these points with a straight line, you'll see that in fact, all of these points are on the same line. Okay, that's because the slope of negative 1 over 2 and 1 over negative 2 are the same slope. They just give you points to either side of your starting point. So these are all points on the same line, and I've recorded their coordinates in my table of values. Example 3, if a line has a slope of 1/3 and the line passes through point negative 2 over negative 1, determine the coordinates of a point to the left and right. So I want points to the left and right. Okay, so let's see what's going to happen here. So my starting point is at negative 2, negative 1. So I know that's an xy coordinate. So that point is right here. So I know that this is the x-axis, my horizontal line. This is my y-axis, the vertical line. So when x is negative 2, y is negative 1, that's my starting point. Now let's use the slope of 1 over 3. I know 1 represents the rise, 3 represents the run. A positive rise means goes up 1. A positive run means goes to the right, so right 3. So up 1, right 3 from our starting point. Up 1, right 3, 1, 2, 3. Here's my point. So I've now found a point to the right. What are the coordinates of this point? This point is at 1, 0. So to the right, 0.1, 0. Okay. How would I find a point to the left? Well, I need to do the exact opposite of what I just did for this one. So I went up 1, right 3. To find another point on this line, I must, to the other side, I must do the opposite of going up 1, right 3. I must go down 1, left 3. So down 1, left 3 is a point right here. So in fact, I used the slope for this one. I went down on right 3, so that means I used the slope of -1 over -3. Okay? And this is equal to the slope that it told me in the question, the slope of 1 over 3. -1 divided by -3 will give me the answer 0.3333, the same as +1 divided by +3. A negative divided by a negative is equal to a positive. Okay, so these two slopes are in fact equivalent. They just, if I use this one, it gave me points to the left. If I use this one, it gave me points to the right. But all of these, both of those points were both on the line. Okay, so both of these slopes were equivalent. They both had the exact same, value. Okay, so what I have here, I'll connect these with a line to show you that these are in fact on the same line. These are all on the same line, these points. Okay, so if it tells you the slope is 1 over 3, that means up 1, right 3, that'll give you points to one side, then just do the exact opposite to find points to the other side, down 1, left 3. And in fact, those two slopes are equivalent. -1 divided by -3 is equal to +1 divided by +3. They just give you points to either side of your starting point. So the coordinates of this point that we just did right there, the x-coordinate is -1, 2, 3, 4, -5, and the y-coordinate, -5, and the y-coordinate is -2. So I've now told you points to the left and to the right. Okay, now let's do this algebraically now. Okay, so without actually having to graph, I'll give you the slope, I'll give you a point, you tell me a possible another point on the line. Okay, so a line segment has one endpoint at -2, 7. Keep in mind that's your x and your y, and it has a slope of -4 over 3. Find the coordinates of another point on the line. So first thing you have to decide whether you want this negative to be in the rise or the run. It doesn't matter. Either way you do it, you'll get a different point, but you will, in both cases, you'll get a point on the line. If you put it into the numerator, you'll get a point to the right of your starting point. If you put it in the denominator, you'll get a point to the left. Let's put the negative sign to the numerator for this case. Okay, we put in the numerator. That means we know our numerator is our rise. Okay, and our denominator is our run. Therefore, the line has a rise of -4 and a run of 3. Okay, I know the rise is the vertical distance, so that changes the y-coordinate, and I know the run is the horizontal distance, that changes the x-coordinate. So that's why we want to, in order to find a new point, all we have to do, since we know the rise affects the y-coordinate, all we have to do is add the rise to the y-coordinate, so add the rise to the y-coordinate, and add the run to the x-coordinate to find another possible point on the line. So I added the rise, -4, to the y-coordinate. So the y-coordinate was 7. I added -4 to it, and I added the run, 3, to the x-coordinate, which was -2. And this will give me a new point. So the x-coordinate is -2 plus 3, that's 1. The y-coordinate 7 plus -4, adding a negative is just subtracting, so 7 minus 4 is 3. That is another possible point on the line. No, we could have also subtracted the rise and run to find a point to the other side of our starting point, and that would have been fine as well. There's an infinite number of solutions for these types of questions. You could add multiples of the rise and the run to find points further along the line, and so on, okay? Or we could have, at the beginning, we could have moved our negative sign to the denominator instead, and that would have found us a point to the other side as well, okay? So there's lots of different things you could have done here. Let's do another example just like this. So a line segment has one endpoint at 3, -5, so that's our x and our y coordinate, and it has a slope of -7 over 2. Find the coordinates of another point on the line. So first of all, let's decide if we want the negative to be in our numerator or denominator. Let's put it in the numerator again, so -7 over 2. Okay. Now, what we need to do, we need to think about how can I find another point on the line algebraically. So I know this is my rise. Okay. So this is my rise, and I know rise is the vertical distance, or the change in y. I know the denominator is my run. That's the change in the x-coordinate, or the horizontal distance between 2 points. So if my starting point is at 3, -5, I know the next point is going to have a rise of -7, so it's going to go down 7, and have a run of 2, so it's going to go right 2. So let's just add my rise and my run to my original point, and that'll give me a new point. Okay, so new point equals. I know the x coordinate of my original point was 3. I need to add the run to that because the run affects the x coordinate. Okay, because that's the horizontal distance between 2 points. So I need to add 2 to that. And then the y coordinate of my original point was -5. I need to add the rise to that because I know the rise affects the y coordinate because it's the vertical distance between 2 points. So I need to add -7 to that to get my new point. And let's evaluate this. 3 plus 2 is 5. -5 plus -7, adding a negative is subtracting, so -5 minus 7 give me -12. So this is a possible other point on the line that has a slope of -7/2 and goes to the point 3, -5. And like I said, there's an infinite number of solutions to these types of questions. Okay, so that's it for this lesson. Hopefully you have a good grasp of what a slope is. And make sure you download the worksheet from jensenmath.ca and let me know if you have any questions.